The topic to be discussed here is a 7 segment display. 7 segment display. 7 segment display. The 7 segment display has 7 LEDs called segments arranged in the shape of number 8. One important point here is the 7 segment display has 7 LEDs. 7 LEDs called segments. Arranged in the shape of number 8. Arranged in the shape of number 8. The number 8 is like that. Shape of number 8. They are easy to use and cost effective. Next point here is most 7 segment display actually has 8 segments, which with a dot on the right side of the segment display. 7 segment display that serves as a decimal point. This one is the eighth number. Most 7 segment display actually have 8 segments with a dot on the right side of the 7 segment display. This is the dot here. Dot. Each segment is named with a letter A, B, C, D, E, F, and G, and the DP for the decimal point. This is the DP, decimal point. Decimal point. This is the shape of that 7 segment display is 8th number. Generally, 8 segments are used. 7 segments are allocated some letters A, B, C, D, E, F, G, and one more is right hand side of that display. That is decimal point shown in figure. Next one is pin configuration. Pin configuration. Generally, this is the 7 segment display pin configuration. 1, 2, 3, 4, 5 here. 5. 1, 2, 3, 4, 5. 10 pin configurations. 1, 2, 3. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here A, B, decimal point here. This one is C, COM, common point here. E, D. This one is common point here. Next one is this one is G. This one is F. These two are internally connected. Common points are internally connected. Out of 10, the 8 pins A, B, C, D, E, F, G, and DP, decimal points, are connected to the digital pins of the Ardunio. Out of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pins. Out of 10, the 8 pins, that is A, B, C, D, E, F, G, and DP, decimal point also. are connected to digital pins of the Arduino. Digital pins of the Arduino. Digital pins of the Arduino. The pins 3 and 8. This is the third pin. This one is the 8th pin. The pin 3 and 8 are internally connected to form a common pin. The pins 3 and 8 are internally connected to form a common pin. Shown in figure. These are the pin configuration numbers are like that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 pins are there. Out of the 10 pins, 8 pins A, B, C, D, F, G and DP decimal points are connected to digital pins of the Arduino. The remaining 2 pins, that means 3 and 8 pins, are internally connected to form a common pin. This common pin is connected to ground or 5 volts. Generally, this common pin, this is the common pin is connected to 0 volts or 5 volts. Depends on the type of configuration. Type of display depend on the type of display. Next one is a common anode configuration. Common anode. Here for each segment, generally 8th number. This is the 8th number. These are the segments. In each segment is mentioned with some letters A, B, C, D, E, F, and G. Small f, small g. A, B, C, D, F, G. Each segment is having some LED indicated by some letter A, B, C, D, E, F, G. Generally in common, this is the common anode display, 7-segment display. In common anode 7-segment display, all the anodes, this is the shown in figure here. This one is the consider 1, 2, 3, 4, 5, 6, and 7. These are the 7 LEDs for 7 segments. 7 segments means 1, 2, 3, 4, 5, 6, 7. In common anode, all the anode connections are joined together. All the anode connections are joined together and finally connected to VCC. That means 5 volts. 5 volts. The individual segments. These are the individual segments. Individual segments are illuminated by applying the ground. That means these are the applied to ground. Individual segments. These segments are numbered here. This one is A, B, C, D, E, F, and G. One more point is also that is a decimal point. Whenever Arduino board pin is assigned to the decimal point, that should be high value. Okay. Suppose A is on, the remaining are off. Black color indicates off. That means indication here is here A, B, C, D, E, F, G, and the DP, decimal point. A is 0. A is connected to 0. The remaining B, C, D, E, F, G is connected to 1. A is equal to 0 means here 5 volts is applied at the anode and 0 volts is applied at the cathode of the A segment. Therefore, this LED is forward biased. That is the reason on condition. And DP, at each and every step, DP must be high. Here DP on right hand side, some decimal point here is there. The decimal point is in, this is the decimal point. The decimal point is indicated red color, that is high. The decimal point indicated here is high. Okay, these are the value is 1. This is the common anode configuration. Common anode configuration. Come to next one. If you want to in common anode configuration, by using common anode configuration, display these numbers on the screen. This is the 1, 2, 3, 4, 5, 6, 7, 8, 9. This one is A. This one is B, C, D, E, and F. These are the numbers are to be displayed on the 7 segment display. Next, coming to sketch. In that sketch, if you want to display here, this one is this one is 8th one, 8th number. If you want to display 0, these are the letters. Segments are indicated with some letters here. Some letters are A, B, C, D, E, F, and G. If you want to indicate 0, this is the 0. This is the 0. Here A, B, C, D, E, and F. A, B, C, D, E, F. Here A, B, C, D, E, F. For A segment is on condition, previously mentioned. A, B, C, D, E, F are connected to ground. Here this one is 0 for 0. A, B, C, D, E, F. A segment LED must be forward biased. Must be forward biased means A is equal to 0, and anode of that first segment is connected to VCC. This is the first segment LED. This is the second segment LED. First segment, second, third, fourth, fifth, sixth, and the 7 segments. 7 segments LEDs, anodes are connected to VCC. Cathodes to be eliminated. That means cathodes are connected to ground. If you want to display 0 number, the cathodes of first segment and the second segment, third segment, fourth segment, fifth segment, and the sixth segments are set to low. These are the values are set to low. Therefore, from first to 6 segments, LEDs are forward biased and on condition, and 0 is displayed. But seventh one is here is reverse biased. That means G is connected to here. G is connected to logic 1. G is connected to logic 1. That is reverse biased. G is connected here. G. By using this principle, by using this one, here A is connected to 0, B is connected to 0, C is connected to 0, E is connected to 0, D is connected to 0, E is connected to 0. F is equal to 1. F is equal to 1. If you want to display 1, this is the one by using here red color. Red color means on condition. This is the 1. 1 means only B and C are zeros. B and C are zeros means the remaining A is 1. A is 1. B is equal to 0. C is equal to 0. E, D, E, F are 1. Reverse biased. In this way, have to write the sketch for this. Display the numbers from 0 to F. Sketch one, important sketches. Here we use a switch case. Here integer, some count is equal to 0. Initially count is assigned to 0. Here A segment is assigned to 13th pin of the Arduino. B segment is assigned to 12th pin of the Arduino. C segment is assigned to 11. D segment is assigned to 10. E is assigned to 9. F is assigned to A. B, C, D, E, F, G assigned to 7. Decimal point is assigned to 6. These are the 13, 12, 11, 10, 9, 8, 7, and 6 are the digital pins of that Arduino board. Digital pins of that Arduino board. First, you have to design these, define these pins configurations by using this one. Integer count 0 completed. Next one is void setup. Void setup. This one for integer I is equal to 13. I greater than or equal to 6. 6 pins, 13 to 6 pins of that these are the digital pins that Arduino board defined in this fashion by using for loop. I minus and pin mode I output. Pin mode I output. This one Pin mode I output means here I is equal to indication is a pin mode. Initially I is equal to 13 output, and I value is decremented pin mode 12 output in this fashion up to 6 output. These lines indicates output up to 6 pins, digital pins from 13 to 6. Coming to, if you want to display, switch action, switch function is used here. Switch function. Next, void loop. This one is a void loop. Void loop. Switch. Count. Initially count is 0. At the beginning, that count value is 0. Count is 0. Case 1. Case not 1. Case 0. Case 0. Case 0 to 15. If you want to display the numbers from 0 to F, 0 to 15. 15 cases are there. Case 0 for 0. A, B, C, D, E, F. This is the 0. In common anode configuration, for segment A is on condition, A is connected to low, B is connected to low, C is connected to low, D is connected to low, E is connected to low, F is connected to low, and G is connected to high. G is connected to high, and the decimal point is also connected to one more here, decimal point here. Decimal point is connected to high. High or low, later we will see in the demo, in demonstration. Okay, next. Here A, B, C, D, E, F, G, decimal point. 0, E is connected to 0, B is connected to 0, C is connected to 0, D is connected to 0, E is connected to 0, F is connected to 0, G is equal to 1, DP is equal to 1. For case, by using these are the digital pins are assigned to these segments 13, 12, 11, 10, 9, 8, 7, and 6. Okay. For case 0, by using these conditions, we have to write some code. Case 0, digital write, digital 13 is low. 13th pin of Ardunio board, that is digital pin, is assigned to A segment of the LED. A segment, and the 7 segments is related. A segment. Next one, digital write. Digital write. 12 low. Digital write. Digital write, and 12 means 11 low. Digital write 10th is also low. Digital write. Digital write 9 low. Digital write 8 low. Digital write 8 low. Next one. Digital write 7 pin high. All are here, some semicolons are there. Digital write sixth pin, suppose set high, we will see what happened. No need to close this one because 16 cases are there. This is the case 0 for 0 display and the 7 segment display. Next, coming to next one for case 2, case not 2, case 1 for case 1, case 1, case 1 is 1. Next, case 2 is for case 2 is for 2, case 3 is for 3, case 4, case 5, case 6, case 7, case 8, case 8, case 9, this is the 9, ten means case A, 11 means 11 means B. Next K, this is the case 10, case 11, case 12, case 12 for C, case 13, D, case 14, E, case 15, F. For all these cases, write a sketch in this fashion. For case 1, suppose for case 1 means only B and C are on, the remaining B and C are connected to ground, the remaining segments are connected to high. That means only A is 0, B is equal to 1, C is not 0 here. Some A is high, B 0, C 0, D, E, F, G, DP. That means here assign A segment to, this is the A, B, C, D, E, F, G and H for case 1. This is the 13th pin assigned to A, high, digital write 13 high. 12 pin is assigned to B, that is low. Digital write 12 pin is low. Like that. In this way, have to write all cases up to 15 cases. Right after all these cases are completed, break, close the curly bracket, because initially switch count, for switch count, here void loop, some curly bracket is open. End of the program. The curly bracket is closed. The curly bracket is closed. This one is closed. Okay, next one. Here are some break is also there. Break is indicated here. Some next. Here some break is also there. After that break, case 1 is start, case 2, case 3. Case 1 is completed, indicate some break. Case 2 completed, indicate some break to 15. After that break, curly bracket is closed. If count COUN capital letters less than 16, 0 to 15, less than 16, that means 0 to 15. Okay. Count plus plus. Count 0 per 0 display less than 16. Next go to count plus plus, that means 1 less than 16 for one display. 2 less than 16 to a second number display, like that. Count is incremented. Delay 1000 milliseconds and the curly bracket is closed. If count is equal to 16, if count is equal to 16, okay, and the set again count to 0 and set again count to 0, count to 0, delay 100 milliseconds, 1000 milliseconds, that is closed. That is closed. And finally one more closing bracket is there. This is the display of the numbers by using a 7 segment display. Now with the help of this one, this is the code. This is the code. Initially count is equal to 0. Initially count is equal to 0. 13, 12, 11, 10, 9, 8, 6. 7, 6 digital pins of the Ardunio board are defined in this fashion. Next, we use a switch statement, switch count, case 0. This is the case 0. Different cases are there. This is the case 0. For display this number, display this one, 0 displayment. This one is A, B, C, D, E, F. This is 13, 12, 11, 10, 9, 8, and 7th pin. This is the 7th. 7th pin must be, this is the 7th pin must be low, the high value. In common anode configuration, 7th pin, this is 13th pin. 13th pin is low, 12th pin is low, 11 is low, 10 pin is low, 9 is low, 8 is low, and 7 is low, and 7 is high. Here some 7 is there, that is the G is high, and common decimal point DP is also high. Common decimal point D is also high. Now I'm coming to for case 1. Case 1 is particularly meant for. Case 1 is particularly meant for one display. For one display, B and C are low. B and C. B and C means B and C segments are assigned to 12 and 11. 12 or 11 are low in case 1. In case 1, 12, 11 are low. In this fashion, I have to cover 15 cases, case 1, case 2, case 3, case 4. At each and every case, some break is there. Here break. Here some starting curly bracket is there. Here switch, after switch count, one curly bracket is there. Already missed this one. This one already missed here. Here switch, some curly bracket is there here. For case 1, these are the functions. For case 2, for case 3, for case 4, up to 15 cases. These are the cases for displaying numbers from 0 to F. After that, break is there. Close this one, curly bracket. If count is less than 16 means count value 0 to 15. 0, initially 0, less than 16. Count value is incremented and delay is there. And if count is equal to 16, that means count should be 0. Reset again, reset counter value is equal to 0 and repeated these things. These are the sketch explanation related to 7 segment. Next, start. Next one, these are the connections. That this is the A, B, C, D, E, F, G. These are the 8 pins, and the DP also, and the DP. These are the 8 pins. These 8 pins of that 7 segment display is connected to 8 digital pins of the Ardunio board. These 8 digital pins of the Ardunio boards are numbered from 13 to 6. 13, 12, 11, 10, 9, 8, 7, and 6. Next, common point here. Some common point is there. That common point is connected to. This is the common point. That common point is connected to 5 volts. That common point is connected to 5 volts because all the anodes of that 7 segment display LEDs are connected to VCC. This is the 3rd pin and 8th pin are the common pins are connected to VCC supply. VCC. This is the 5 volts. The remaining A, B, C, D, E, F, G, and decimal point are also connected to digital pins of the Arduino board through these resistances, 330 ohms resistances, 1, 2, 3, 4, 5, 6, 7, 8 resistances. This is the circuit diagram. Start simulation. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and the count is 0 again. Suppose if you here decimal point is also there, here this is the DP point. Suppose if you want to glow this DP point here, instead of I, that should be low. Low for case 0. Low. low. All our DP points are connected to assigned to low value. Okay. The DP point is connected to 6th pin of the Ardunio. 6th pin of the Ardunio. This is the low. Low. This one is low. Connected to low here. Okay. Now start simulation. This one decimal point is also glow. 5 dot 6 dot 7 dot 8 dot 9 dot A dot B dot C D E F again 0 1 2 3 and so on. With this, the demonstration of 7-segment display is completed. Display the numbers from 0 to F. If you like this video, please subscribe the channel for further updates. Thank you.